Hi, Matt. Excuse me. Sorry, I just wanted to add one very short addendum to the last one. I noticed, well, I was thinking about that thing about deciding whether or not to terminate that reading loop based on the number of bytes received, and the possibility of the number of received bytes on the last read being exactly the requested size. Well, it turns out that, in fact, that led me to discovering a bug, and so I fixed the bug, and I suppose that's in here. No, that would be in here. In this response, or this loop, now the way it was working before, I'll just show you the difference. I can get down there. All right. Well, the outline is correct. It's not error occurred, but this part is the same. In fact, I haven't changed this code. Although there's some, because of some of the subtleties involved in this function, reality, there's a subtle change. Well, maybe change in the way of viewing it, but the way in which this is used, response of bytes. Here it calls InternetReadFile with the base one with the double colons and some other arguments, and what it used to say is that there's more data if the buffer was completely filled, right? And so I looked at the help on InternetReadFile. It's probably still up here. A normal read retrieves so many bytes for each call until the end of the file is reached. To ensure that all data is retrieved, an application must continue to call the function until the function returns true and number of bytes read equals 0. Well, we haven't done that. Okay, we've read, even in the cases where it's seemingly succeeding, we've read up to a point where we didn't get more than our 1024, and it stopped. And then it goes on to say, this is especially important if the requested data is written to the cache, because otherwise the cache won't be properly updated, and etc., etc. The file won't be committed to the cache. So, although we're not using the cache, this function should work properly. So the way that this response thing works now, changed, is now remember I said this function hasn't changed. It hasn't. However, if dw, the number returned, happens to be 0, right, then this call will free the buffer PV and return 0, assigning 0 to this PV. Turns out that's one of the magical things that reality does for you. And probably one of the reasons why it does those weirdo things is because people write code like this, and half the time when you get a 0, you want to free the buffer. Like for repeated reads. Now, otherwise, right, we will have read some amount of data into this PV, and that will be the number dw. And succeeded will be true. Now the only time this now will never fail. We'll never get has succeeded is false, turns out. But we're going to get one more read because of the way I've rearranged it. We do response of bytes, okay? Now, if the buffer comes back as non-null, I just store into buff, same as before, a buffer of size this with using this pointer, right? Oh, and I also added this auto-free. I wasn't freeing that buffer either. But that's of less importance than this. Otherwise, it's an empty buffer. And more data is assigned to whether or not PB is null, which is what we're supposed to do, right? So that returns true and number of bytes read is 0. When number of bytes read is 0, this becomes 0 and this is null. So I could also use this as an indicator, but either way, we simply return true, okay? The only false condition is when this fails, which is okay. So now this thing is returning false only when this is returning false, so on a real error. Okay, now back to that loop. Loop forever. I call this, if this fails, which it never should, return false. If there's no more data, then break. Now this flag gets set when we read only when we read nothing, right? There won't be anything to add here. Okay. So now it could be like before. This skips the step of adding an empty buffer to a buffer. And it works the same, and we get the right number of characters. However, now it doesn't have that bug. The bug that, same number. The bug, first, it doesn't have the memory leak that was there, we never noticed. And if we're using the cache, it will get the cache will work properly. That would be a pretty subtle bug to try and track down, and you know, and I'm sure that the first person who wrote this probably didn't know about that, and that bug may have been carried along for ages. And probably a lot of code contains that bug. If you'll notice, the internet cache doesn't really work the way you expect it to for many things, right? Okay, so I just thought I'd mention that. Fix.